Welcome to our deep dive, and this time we're tackling something that impacts everyone every single day. That's right, we're talking weather. You guys send in so many sources, everything from the basic explanations to how forecasting actually works.
Yeah, it's amazing how much there is to uncover about something we experience all the time.
Exactly. So think of this as your ultimate guide to understanding weather and a good way to impress your friends with some, cool weather facts.
It really is relevant to all of us. I mean, weather shapes so much of what we do, how we live our lives.
Oh, totally. I mean, who hasn't had their weekend plans completely messed up by a surprise storm or a heat wave?
So true. So before we get into all the complicated stuff like air pressure and jet streams, maybe we should start with the basics. Like what exactly IS weather?
Well, one of the sources you sent, Harmony Square, puts it pretty simply. Weather is basically what's happening in the atmosphere at any given time. So that means rain, wind, sunshine, snow, you name it.
It's more than just something we see, though. Weather is a real force. It shapes our planet, it impacts ecosystems, it affects our lives in huge ways.
You're right. I mean, just think about hurricanes, blizzards, heat waves. Those things disrupt transportation, agriculture, even our moods, I think.
Absolutely. And it's interesting to think that for so long, people had to rely on just observing nature and folklore to kind of predict what the weather would do.
Speaking of which, Harmony Square mentions some pretty interesting historical methods, like observing bird migration or even how cows were behaving. Cows, really? Like what? If they're lying down, it means rain.
Yeah, apparently. Now, obviously, we've got way more sophisticated tech to help us understand the weather, but those old ways of connecting with nature are still kind of cool.
Okay, so we agree weather's important. But
Yeah,
where does it all actually happen? We can't see the atmosphere, can we?
true, but it's there. This layer of gas is all around our planet, and it's crucial to how weather works.
Harmony Square breaks it down into different layers, kind of like I don't know, a layer cake or something. And each layer's got its own unique properties.
And all the weather action that we experience, that happens in the very first layer, the troposphere. Think of it like Earth's weather factory, I guess.
Okay, so the troposphere is where it all goes down, but what exactly is going on in there that creates these weather patterns?
Well, Harmony Square and small town weather as well, they both talk about the three main ingredients: air, water, and heat. And it's how these three interact that creates all the crazy weather phenomena that we see.
All right, so let's break it down. Starting with air, what makes it move around?
It's all about density. Harmony Square explains that cold air is denser than warm air. Imagine it like this. Cold air molecules, they're all huddled together, while warm air molecules are more spread out, more energetic.
So what happens when you get these different air densities interacting? Does that cause, conflict?
It's kind of like a giant convection oven, you could say. The sun heats up the Earth, but it does it unevenly. So you end up with areas of warmer air and cooler air. And warm air, you know what they say about warm air.
It rises, right.
Exactly. And as that warm air rises, it leaves behind an area of low pressure. Nature really doesn't like these empty spaces, so the cooler, denser air rushes in to fill the gap. And that movement, that's what we call wind.
So that explains wind. But what about those high pressure and low pressure systems they always talk about on the weather reports? Where do those fit in?
Good question. High-pressure systems are linked to sinking air, which basically stops clouds from forming and usually means clear skies. On the flip side, low-pressure systems, those are all about rising air, which carries moisture up into the atmosphere, and that leads to, you guessed it, clouds and precipitation.
Wait, so high pressure means the air is pushing down. Wouldn't that, trap the clouds and moisture? It seems like the opposite of what you'd expect.
I know it sounds counterintuitive, but think about it this way. As the air sinks in a high-pressure system, it actually warms up, and that means it can hold more moisture. So any clouds that were there, they tend to just evaporate. Like squeezing a sponge, it forces the water out.
Oh, okay, I see. So high pressure is kind of like a giant invisible hairdryer for the atmosphere.
You got it. And then you've got this other cool thing called the Coriolis effect, which comes from the Earth's rotation.
The Coriolis effect, yeah, I've heard of it. Always sounded kind of complicated, though. Can you break it down for us?
Okay, imagine you throw a ball straight north from the equator. Because the Earth is rotating, the ball's not going to go in a straight line, it'll curve to the right.
So it's like the Earth is putting a spin on everything, right?
Yeah, exactly. And this spin has a big impact on how wind patterns work. Instead of blowing directly from high pressure to low pressure, the wind gets deflected. So you get those swirling patterns we see on weather maps.
I never realized that the Earth spinning could affect something like wind so much. That's
Yeah.
wild.
And fun fact, you can actually see this Coriolis effect in how hurricanes spin. They rotate counterclockwise in the northern hemisphere and clockwise down south.
That is so cool. Okay, so we've got air and heat making the wind blow, creating those pressure systems. But what about water? What role does water play in all this?
Water is essential. Harmony Square goes into the whole water cycle, which is this constant movement of water between the Earth's surface and the atmosphere.
Right, yeah, evaporation, condensation, precipitation. I remember those from like grade school.
Well, think about what happens when water evaporates from the oceans, lakes, rivers. It turns into water vapor, which is invisible, in the air.
And then it just hangs out up there.
Not quite. As that moist air rises, it cools down, and the water vapor condenses. That means it turns back into tiny water droplets. And here's the cool part. Those droplets need something to cling to, like dust particles or pollen floating around.
So it's like the sky is a giant canvas, and those particles are like the paintbrushes making the clouds.
Exactly. And just like there are tons of types of paint, there are different kinds of clouds. And each type has its own, look and its own impact on the weather.
Harmony Square mentions cirrus, cumulus, and stratus clouds. I vaguely remember those. What's the difference again?
Okay, so cirrus clouds are the wispy, high-altitude ones. Cumulus clouds, those are the puffy, cotton ball-looking ones you see on nice days. And stratus clouds are the flat, gray ones that cover the whole sky sometimes.
What about those dark, towering cumulus clouds? Those are the ones that usually mean rain is coming, right?
Yep, those are the rainmakers. And just a reminder from Harmony Square, precipitation comes in all forms. Gentle rain, snow, but also the more intense stuff like sleet and hail.
Okay, so we've covered the basics: air, water, heat, wind, pressure systems, clouds. But what about when things get really wild? Like the big weather events, thunderstorms, tornadoes, hurricanes, those kind of make the news.
That's where things get even more interesting. And believe it or not, it all comes back to those same basic ingredients, just amplified, much more intense.
So let's start with thunderstorms. Harmony Square said there are thousands of thunderstorms happening around the world at any given time. Why are they so frequent?
It's all about how they form. Warm, moist air rises very rapidly and creates those giant cumulonimbus clouds we talked about. And inside those clouds, you've got these intense updrafts and downdrafts, collisions between ice and water droplets. It's like a recipe for some really dramatic weather.
And of course, you can't forget lightning. Harmony Square explains that it's this huge electrical discharge that happens in those storm clouds.
And that discharge heats up the air so quickly that it creates this shock wave. And that's what we hear as thunder.
Right, and we see the lightning first because light travels faster than sound. It's like nature's own sound and light show.
Exactly. But as cool as they are, thunderstorms can also be pretty dangerous. Lightning strikes can start fires, knock out power, and the strong winds can bring down trees and damage property.
And then you've got tornadoes, those terrifying spiraling columns of wind that can cause so much destruction. What causes them?
Tornadoes form over land when you have different air masses colliding. And these air masses have wildly different temperatures and humidity levels. And that creates this crazy instability in the atmosphere, and you get these powerful rotating updrafts.
So it's kind of like a supercharged version of that convection we were talking about earlier.
Exactly. And tornadoes can have wind speeds over 300 miles per hour. That's enough to rip apart buildings and toss cars around like toys.
That's terrifying. It's crazy to think about the power of nature. And speaking of powerful storms, there are hurricanes. Those massive storms that form over warm ocean water.
Hurricanes are like giant engines, and their fuel is warm, moist air rising over tropical oceans. And as that air rises and cools, it releases heat, which makes the storm even stronger.
And they cause huge damage with those high winds, heavy rain, and of course the storm surge.
Right, and hurricanes can travel thousands of miles, so they can impact coastlines far, far away from where they first started.
Okay, so we've got these big dramatic weather events like thunderstorms, tornadoes, hurricanes. But how does that all connect to the idea of climate? That's more long term, right?
That's a great question. And it's important to understand the difference between weather and climate. Weather is what's happening right now, the current state of the atmosphere. Climate is the long-term average of weather patterns for a specific place.
Okay, I think I get it. So weather is like your mood today can be sunny, stormy, who knows. Climate is more like your personality, the overall trends that define you.
That's a really good way to put it. And just like different people have different personalities, different regions have different climates.
Harmony Square talked about the three main climate zones: tropical, temperate, and polar. And it all has to do with how much sunlight each region gets, right?
Right. Tropical zones, those are near the equator, get the most direct sunlight, so they're warm all year round. Temperate zones, like where we are, we experience more distinct seasons with warm summers and cooler winters. And then the polar zones at the top and bottom of the Earth, they get the least sunlight, so it's super cold there.
So it's all about the Earth's tilt and how that affects the way the sunlight hits different parts of the planet.
Exactly. And this uneven heating of the Earth is what drives those global wind and ocean currents we talked about earlier. And that creates the different climates we see all over the world.
Okay, so we've got a good grasp on what weather is and how it works, but how do we actually predict what's going to happen next? Weather can be so unpredictable, right?
Absolutely. That's where the amazing world of weather forecasting comes in.
And that's where we'll pick up in the next part of our deep dive.
Predicting the weather. It's kind of like trying to solve this giant puzzle, but the pieces are always changing.
And the stakes are pretty high, too. People need accurate forecasts to make decisions about their day, or even bigger things, like whether to evacuate during a hurricane.
You're right. So how do those meteorologists actually do it? How do they take all those factors we talked about, the air, the water, heat, even the Earth spinning, and turn that into a forecast that we can use?
Well, one of the sources, Wendover Productions, gives us a peek behind the curtain, and it all starts with data, tons of data.
It's definitely not just looking out the window and seeing what kind of clouds are out there anymore.
Right. It's this whole network of systems all over the world that are collecting information about the atmosphere nonstop.
Think weather balloons, launched twice a day, radar scanning the skies, those buoys out in the ocean. Even airplanes are gathering data as they fly.
Wow. It's like having a bunch of eyes and ears all over the planet just monitoring what the weather's doing.
And, EUMETSAT, that's the European Organization for Meteorological Satellites, they really emphasize how important global cooperation is in this whole thing. Weather doesn't stop at borders, so sharing data is key for accurate forecasts.
That's true. It's a global effort for sure. So all that data, it's constantly flowing into these weather centers where it gets processed and analyzed by powerful computers.
And those computers are running these super sophisticated weather models, which are basically sets of equations that simulate how the atmosphere is behaving.
Wendover Productions mentioned one of these models. It's called the Global Forecast System, or GFS, and that's the one the National Weather Service here in the U.S. uses for those long-range forecasts we see.
But it's not like you just plug numbers into a computer and boom, there's your prediction. Small Town Weather pointed out that it takes human expertise and experience to actually interpret those model results and understand what's going on.
So it's not just about the tech, it's the people behind it too, right?
Exactly. Those meteorologists, they're like weather detectives, piecing together all the clues to figure out what's going to happen.
And they have to do it quickly, accurately, because people depend on it.
Yeah, a good forecast can help farmers, warn people about hurricanes, even keep air travel safe.
So let's talk about the National Weather Service here in the U.S., the NWS. They're kind of the big players in getting forecasts out to the public, right?
Absolutely. Small Town Weather calls them the Authority for Weather Info in the U.S., and their whole mission is to protect life and property and help the economy.
They've got these local weather forecast offices, WFOs they call them, all across the country. Each one's responsible for their own region.
And Wendover Productions made a good point about how those local offices take the national forecasts and adjust them to their specific area. They have to consider things like the landscape, how close they are to water, even things like the urban heat island effect in cities.
It's cool that each WFO also provides specific info for their area. Like Alaska, they have climbing forecasts for mountaineers, and in Colorado, they issue fire weather reports.
Yeah, it shows that forecasting isn't just about general predictions. It's about knowing the specific needs of different communities.
And when you get big, serious weather events like hurricanes, the NWS has national centers that focus on tracking and forecasting those.
Right, like the National Hurricane Center in Miami. They handle hurricanes in the Atlantic and Eastern Pacific.
And they don't just put out forecasts, they also issue those watches and warnings to alert the public.
Small Town Weather actually explained the difference between watches and warnings, which I thought was interesting. A watch just means the conditions are right for severe weather to develop, while a warning means it's happening or about to happen.
Knowing the difference could be really important, even life-saving. So how does all this info actually get to us? I mean, most people aren't checking the NWS website directly for weather updates.
That's where all those weather apps and websites come in, and the TV meteorologists.
Right. They take the raw data from the NWS and translate it for us regular folks.
But it's important to remember, no matter how fancy the app is, the info's coming from the NWS and all those hardworking meteorologists behind the scenes.
They're like the unsung heroes of the weather world, making sure we're in the know.
And it's not just about forecasting down here on Earth. The NWS also monitors space weather,
Space weather, what's that?
basically stuff happening on the sun, like solar flares and coronal mass ejections. Those can send charged particles towards Earth.
That can mess with our technology, right?
Exactly. Radio communications, GPS, even power grids can be affected.
Wendover Productions even mentioned how that solar radiation can be a problem for airplanes flying over the poles where the Earth's magnetic field is weaker.
Yeah, so we have the Space Weather Prediction Center in Colorado. They keep an eye on the sun and warn us about any potential problems.
It's pretty amazing how weather forecasting isn't limited to our planet anymore.
It shows you how far-reaching weather really is. It impacts everything from our everyday routines to our technology.
So we've talked about how forecasts are made and how they get to us. But let's go back to that example Wendover Productions used that day in early March with a high-pressure system in Minnesota and a low-pressure system in the Gulf of Mexico.
Like, that was a great example of how all those different data points we talked about, from the weather balloons to the buoys, start to create a bigger picture for the forecasters.
And the models predicted that those two systems were going to collide, create this huge storm that would move up the East Coast, bringing snow to some really populated areas.
And that's where the local WFOs really come in.
Right. Wendover Productions explained how the forecasters in, say, New York City would take that national forecast and fine-tune it based on what they know about their area.
They think about things like the city itself, how close they are to the ocean, even the elevation of different neighborhoods.
It's like they're taking that general forecast and making it super specific and accurate for the people who live there.
And when a big storm like that's on the way, the NWS kicks into high gear.
They start issuing those watches and warnings. They work with emergency management folks to make sure everyone's prepared and safe.
And they use all the communication channels they've got, social media, NOAA, weather radio, everything to get the word out.
It's impressive how much effort goes into making sure people are informed when bad weather's on the way.
It really shows how dedicated those forecasters are and how important it is to understand and respect the power of weather.
It really is amazing how much work goes into making those forecasts, and we probably don't even think about it most of the time. But with all this talk about models and data and computers, what about the human element? Like, do those forecasters use their intuition at all?
Yeah, for sure.
Yeah.
Even though technology has totally changed the game, forecasting still has that art to it. Small town weather really stressed that you need that human expertise, especially when it comes to interpreting those complex model results.
So it's not just crunching the numbers, it's understanding the personality of weather patterns.
Right. Those experienced meteorologists, they can pick up on subtle clues, things that the models might miss, and ultimately it's their judgment that makes a forecast really accurate and usable.
It's like adding that human touch to the science, like a chef who can look at a recipe and just know if they need to tweak the seasonings or the cooking time.
That's a great analogy. They bring their years of experience to the table and their knowledge of, local weather quirks. And that's how they refine those model predictions and make a forecast that really works for their specific region.
It's so cool how it's this mix of science, tech, and human intuition. That's what makes weather forecasting so effective.
And it's always getting better. We've seen huge progress in computing power and modeling techniques. Who knows what's next?
Imagine maybe personalized weather forecasts sent straight to our smartwatches, or AI weather bots that can answer any weather question you have.
The possibilities are pretty exciting. But one thing's for sure, no matter how advanced things get, those fundamental forces that drive weather, those aren't going anywhere.
The air, the water, the heat, that dance is always happening.
And as long as that's going on, there'll be weather to watch, to try to predict, and to just be amazed by.
I have to say, this deep dive has been incredible. We've really explored so much about weather forecasting, the science, the technology, the human stories behind it all.
From those ancient ways of observing nature to those supercomputers crunching data from all over the world, weather is something that never ceases to amaze.
It's true. So next time you check your weather app or watch the forecast on TV, think about everything that went into making that prediction. All that data, the tech, the people working behind the scenes.
And maybe take a minute to just step outside, look up at the sky, and appreciate the sheer power and beauty of weather.
Well, that about wraps it up for our deep dive into the world of weather. Thanks for joining us.
We hope you learned a few things along the way, and maybe even gained a new appreciation for the forces that shape our planet.
Keep those questions coming, and until next time, stay curious.